Welcome to today's explainer. Look, if the word trigonometry gives you instant flashbacks to a blackboard completely covered in complex equations, you definitely aren't alone. But today we're going to demystify all of that. We're going to strip away the intimidating formulas and uncover the really fascinating real-world survival tools that actually birthed this whole branch of mathematics in the first place.
It really begs the question, where did trigonometry actually come from? And I promise you, it wasn't just invented to torture students. The math we all learned started as an ancient, incredibly practical survival tool. It was created by early humans who desperately needed a reliable way to measure flooded rivers, build massive monuments, and map the seemingly chaotic stars above them.
Okay, let's dive into this. Here's our roadmap for the explainer. 1. Pyramids to the stars. 2. The birth of sine. 3. Expanding the 6 functions. And 4. Navigating the modern world.
To kick things off, let's just strip away the intimidation factor by breaking down the word itself. Trigonometry literally just comes from ancient Greek words that mean triangle measurement. That's the whole shebang. The absolutely crucial takeaway here is that this entire field of study began simply as a way to use the geometric shape of a triangle to solve highly physical problems. Things like studying the stars, figuring out navigation, and drawing up accurate maps.
Section 1. Pyramids to the stars. Ancient beginnings in Babylon, Egypt, and Greece.
If we travel back over 4,000 years to Babylon, we hit a number that should be incredibly familiar to you, 360. You see, ancient Babylonians used a base 60 number system, and that ancient system is exactly why our circles still have 360 degrees today. It's this perfect, relatable connection, showing us how the practical, everyday decisions of ancient civilizations directly shape the geometry we use right now.
And that really establishes the massive 4,000-year scope of our journey today. We're starting around 2000 BCE with Babylon and Egypt, moving over to Greece around 150 BCE, then dropping into India around 500 CE, and going all the way up to 18th century Europe. We're going to see exactly how one civilization's practical tool was passed like a baton, becoming the very next civilization's massive scientific breakthrough.
Now, back in those early days, humans absolutely weren't using the algebraic formulas we rely on today. They were purely concerned with survival and engineering. Think about it. After a river flooded, they had to measure land boundaries just to reclaim their farms. They needed perfectly precise ratios to build the pyramids. They tracked time using nothing but sundials and shadows, and used basic geometry to map planetary movements. They were using physical shapes and ratios to solve literal, daily problems.
But as civilizations kept looking up at the night sky, the math had to become more systematic. Enter the Greek stargazers. Around 150 BCE, a mathematician named Hipparchus created the first known table of what they called chords. It was essentially an early precursor to the sine function, designed specifically to calculate the massive distances between stars and planets. His work was so groundbreaking that he's literally remembered today as the father of trigonometry. Later on, Ptolemy expanded on all this in his famous astronomical textbook, the Almagest, providing the core formulas that astronomers would rely on for centuries.
Section 2. The birth of sine. India's mathematical leap.
To truly grasp this next leap, we have to look at how they actually measured things. The Greeks calculated using a full chord, which is just a line connecting 2 points inside a full circle. But an Indian mathematician named Aryabhata introduced this revolutionary, yet beautifully simpler concept around 500 CE, the half chord, or ja. By focusing on just the half chord, it formed a perfect right triangle. Having that super reliable 90-degree anchor made astronomical calculations incredibly simple, and it laid the direct foundation for the modern sine function.
Now, what is truly fascinating here is the incredible linguistic evolution of how we actually ended up with the word sine. It is a wild ride. It started as jaya, the Sanskrit word for half chord. Then Islamic scholars adapted it into Arabic as jiba. But later, when European scholars were translating those texts into Latin, they completely mistook jiba for a totally different, but similar-looking Arabic word meaning a bay or a fold. So they translated it into the Latin word sinus. And over time, sinus became the English word sine. That's right, one of the absolute foundational pillars of mathematics was literally born from a mistranslation.
Section 3. Expanding the 6 functions. The Islamic Golden Age.
So between the 8th and 14th centuries, scholars in the Islamic world took all that combined Greek and Indian knowledge, merged it together, and built something much, much bigger.
Brilliant scholars like al-Battani and al-Khwarizmi truly expanded the entire discipline. They developed formal table values for all 6 primary and reciprocal ratios: sine, cosine, tangent, cotangent, secant, and cosecant. They completely fleshed out the mathematical toolkit. And perhaps the most pivotal moment of this entire era came from a 13th century scholar named Nasir al-Din al-Tusi. He did something completely unprecedented at the time. He wrote the very first work that treated trigonometry as its own standalone branch of mathematics. Up until then, remember, it was really just a helper tool for astronomy. Al-Tusi gave trigonometry its total independence.
Section 4. Navigating the Modern World, the European Renaissance to Modern Day.
During this era, this ancient star-gazing helper tool became the absolute engine for global exploration. In the 15th century, a mathematician named Regiomontanus published the first systematic European textbook on trigonometry. By reintroducing these advanced methods to Europe, he provided the exact math needed to drastically improve ship navigation. Without trigonometry, sailors simply couldn't accurately cross the open oceans. This ancient math directly empowered the age of exploration.
And that brings us to the 18th century and a brilliant mathematician named Leonhard Euler. Euler is pretty much the reason your high school textbook looks the way it does today. He standardized the modern mathematical shorthand we all use, popularizing the abbreviations sin, cos, and tan. But even more importantly, using calculus, he linked trigonometry with complex numbers. He essentially turned ancient geometric shadow ratios into the smooth, continuous mathematical functions that completely drive modern physics and engineering.
So from measuring flooded riverbanks in ancient Egypt to tracking planets in Greece, simplifying chords in India, expanding functions in the Islamic Golden Age, and eventually navigating the global oceans, trigonometry is this epic 4,000-year story of human collaboration forged out of pure, basic necessity. Which leaves us with one final provocative question to think about. Based on the rapidly changing needs of our modern world, which area of math do you think will evolve next? Keep that in mind, and thanks so much for joining me on this explainer.